This is a tremendously oversimplified model. Um, Obviously, even the logistic growth equation doesn't contain a lot of real-world detail. It is, however, possible to make these models much, much more complicated. So they actually can be used to do things like, say, manage wild populations of organisms. But I want to bring in one point and remind you that you have to be very careful when you use these models, because models oversimplify reality. In particular, they make assumptions. Okay, and sometimes when those assumptions don't actually hold true in the real world, it doesn't matter. Okay, so for example, what we generally try to go for when we build a model is you build a model that does a pretty good job of predicting what goes on in the real world. It may not track every wobble in the size of a population, but if it gets the general trend right, reliably, decade after decade, then you feel pretty confident that you can use this model to predict what's going to happen in the future, and you can rely on that prediction. Um, However, you have to be sure that you've included everything that is important in your model. If some of the assumptions of your model turn out to be false, it can give you wrong predictions about what's going to happen in the future, and that can be really devastating. I have this fishing boat up here because devastation is exactly what's happened to many of the world's fisheries. Sorry about the bad quality of this reproduction, but this is a study that was done recently suggesting that if fishing trends continue the way that they are, then by the year 2050, only about 10% of the world's major fish stocks will still be fishable. Many of the fisheries that are out there now have collapsed. About a quarter of the world's fisheries have collapsed. That means they've been fished so hard for so long that the populations have gone to 10% or less of their historical maximum. The problem is when a population is that small, it can only grow very slowly. Remember that when the train is only pulling one freight car up the hill at a time, it's delivering freight really slowly. The only thing you can do when a fish population in the wild collapses like this is you have to let it alone. You have to let it wait. And that means it can't be fished for years and years and years while that population is recovering. This is an economic disaster for some people when this happens, and it can also be a public health disaster because you can have famines occur. You can have large numbers of people who are malnourished or may even start dying if a major source of their food is suddenly gone. Okay, the reason why I'm bringing this up in the context of models is that a model something like the ones that we've been looking at has been used before to suggest, what rate at which it is okay to take fish out of a population. This approach was called the maximum sustainable yield approach, and it was founded on very solid mathematics. It made these very clear predictions, and when people tried to follow those predictions, fisheries collapsed. Turned out you could not fish that many fish every year and have the fisheries survive. That's because the model that they were working with, a super simplified model that managers were working with, didn't take into account the fact that, the carrying capacity actually is not a constant. Some of the years you have good years and the environment would be able to support, let's say, 25,000 fish. Some years you're going to have bad years and the environment might only be able to support 20,000 fish. On average, it might be wobbling around, let's say 22,000. Maybe that's, your average carrying capacity from year to year. But if you set up your model such that it's saying, okay, the carrying capacity of this is 22,000, it stays the same every year, you're actually going to send the population, and you fish out as many fish as you think the population can handle, you're actually going to send it into what's called a death spiral. You're going to knock the population down each year farther than you thought you were. That means it's going to have more trouble growing. Growth is going to be slowed down, and so the next year will knock it even farther down, and so on. And that's how fisheries collapse, is when overfishing starts to diminish the population's ability to add enough individuals to basically make up for the amount that are being fished out. Again, the upshot is that if you're going to use a model to do anything important, you have to make sure that your assumptions, the assumptions that are going in the model, roughly check out. Or at least, the very least, you need to make sure that the assumptions that you're making don't matter to the behavior of the model that you're really interested in.